This is lecture 28, and we'll do more problems on absolute maxima minima. So let's say we have question number 34. Okay, so it's a question number 34. So question is, we have a function txy. Okay, that is x square plus xy plus y square minus 6x. And this time we have given a plate, a rectangular plate, as our domain with x lying between 0 to 5 and y lies between -3 to 3. Right? So on this domain, we want to find out the maxima and minima, absolute maxima and absolute minima, of course. So let's start and see how it works. So first of all, let's plot the domain. So let's say your x is lying between 0 to 5 and y is from -3 to 3. So something like that. And x right, so that is there. Your x lies between 0 to 5. That means x0 is y-axis and x5 is this line, which is parallel to the y-axis, and this is our x-axis, and this is a line which is parallel to x-axis, y is equal to 3 and y is equal to -3. So we have this much of area, right? This is with us, and we want to find out the maxima and minima over this region. True? Yes. Are you with me on this?
Yes, sir.
Yes, sir.
First of all, try to calculate the local maxima and minima for this function, and then we'll restrict our things to the boundaries, right? As we have done in the last class as well. So we have t of xy as x square plus xy plus y square minus 6x. So let's start with tx. So that is 2x plus y minus 6, and ty, and that is x plus 2y. So we'll keep them equal to 0. So that is 2x plus y is equal to 6 and x is equal to -2y. So let's put x is equal to -2y over here. So 2 minus 2y plus y is equal to 6, minus 4y plus y is equal to 6. So y is equal to -2. So if your y is -2, so put that value over here. So what do you get? You get x is equal to 4. So your point is 4 and -2, right? So now you just get the value on that point. So this becomes t4 minus 2. So that is 4 square plus 4 into -2 plus -2 square minus 6 into 4. So this becomes 16 minus 8 minus 4 minus 24. Right? So this is what? 28, 36. So -20. Is it fine?
Sir, +4 नहीं
Plus
आएगा?
4.
Where it is? Yeah, it should be +4. So let me correct this. So this should be +4 minus 24. Yes. So -20 and +8. So -12. Right?
Yes.
Is it fine? Okay. So this is our first value, that is -12. So let's try to calculate the things one by one on the boundary. Okay. So First of all, assume x is equal to 0. So first thing, your x is 0. So put that x is equal to 0. That means t0y, which is equal to what? X square, that is 0, plus xy again 0, and then plus y square minus 6x, that is again 0, right? So therefore your t0y is y square. That means now if you take t dash, this becomes 2y, which is equal to 0. So your point is x0 and y0, right? So from here y0, so point is, so let me write it in this way. So point is 0 0. Okay, so now put that point over here. So of course you will get t0 to be 0. So let's mark these things which we are getting, so that at the last we can compare that which is the maximum and which is the minimum. Okay, so let's start with the next boundary, right? And that is what? That is x is equal to 5. So let's put x is equal to 5 over there. So t5y. So if you put x is equal to 5, so this becomes 25 plus 5y plus y square minus 30. So this becomes y square plus 5y minus 5.
एक्सक्यूज मी सर
Yes.
सर जब हमने x इक्वल्स टू 0 पे चेक किया तो हम वो कॉरेस्पॉन्डिंग पॉइंट्स नहीं चेक करेंगे?
कौन से? हाँ, वो हम लास्ट में भी चेक कर सकते हैं, कोई दिक्कत नहीं है।
ओके
सारे
सर।
पॉइंट्स इकट्ठे भी चेक कर सकते हैं ना, ये वाले कॉर्नर वाले।
यस सर।
हाँ, ये सारे बाद में भी चेक कर सकते हैं, ठीक है?
ओके
ये
सर।
वाला, ये बाद में भी हो जाएंगे चेक, ठीक है?
ओके सर।
इकट्ठे भी कर सकते हो एक तरह से। So let's say you have now t of that was 5y. So of course now if you take t dash, this becomes 2y plus 5 is equal to 0. So your y is minus 5 by 2. So therefore now you have chosen x to be equal to 5. So point is 5 minus 5 by 2. Right, so if you put that thing over here, 5 and minus 5 by 2, so let's say put those values over here. So 5 square plus 5 into minus 5 by 2, right, and then plus y square minus 5 by 2 whole square minus 6x, that means 5. True? Okay, so this becomes 25 minus 25 by 2 plus 25 by 2 minus 30. Right, so this will
25
be
by 4.
sorry, 25 by 4. Yes, so this becomes minus 5 minus 25 by 4. Okay, so this becomes minus 45 by 4. Is it fine? Is it okay? So this is your t of 5 minus 5 by 2, so that is minus 45 by 4, right? So let's mark this point as well. Okay, is it fine? Yes, you are with me.
Yes,
So
sir.
now see, you have two corner points. If you want to calculate the value right now, you can calculate these points value at this point. So let's say t of 3 and 5 and 3 and 5 and minus 3. There are 2 points, right? So first it is minus 3 and then it is 3. So let's put these values over here. So 5 square plus 5 into minus 3 plus minus 3 square minus 6 times the 5, and then again 5 square plus 5 into 3 plus 3 square minus 6 into 5. So this becomes, so the values becomes 25 minus 15 plus 9 minus 30 and 25. Let me write it in this way so that no confusion. 25 plus 15 plus 9 minus 30. So therefore, t of 5 minus 3 will become what? This is 10 plus 9, 19 minus 30 minus 11 and 5, 3. 40 minus 30, 10 plus 9, 19. So these are the two values which we are getting from here. Okay. So right now we have calculated these much of values. So minus 12 is minimum till now, okay? And maximum we are getting 19. So now we are left with y is equal to minus 3 and y is equal to 3, right? So these two lines we are, we didn't calculate right now. So let's say now this was the number 2. Okay, actually this was the number 1, but anyways, boundaries we are saying, so that's why it's number 2. So number 3 will be, let's say y is equal to minus 3. So that means t of x minus 3. So x square plus xy plus y square minus 6x. So this becomes x square minus 3x minus xx minus 9x plus 9, right? So therefore t dash 2x minus 9, right? So therefore if we calculate this thing, so this becomes 2x for extreme point, x becomes 9 by 2. So y is already minus 3, so t 9 by 2 and minus 3, this is the point. So that becomes 9 by 2 square minus 9 into 9 by 2 plus 9. Okay, sorry, I mean put this in equation, right? So 9 by 4, 81 by 4 minus 81 by 2 plus 9. So minus 81 by 4 plus 9. So this becomes t minus 81 plus 36 by 4. So minus 45 by 4 again, right? Are you with
Yes,
me?
sir. Yes,
Okay.
sir.
Yes, sir.
So this is the point. Okay. So I mean, next you calculate the fourth thing, that is t of x3. So that will be just similar, except this sign. This sign will be positive, right? Otherwise, everything will be same. So this sign, sorry, this sign will be positive. So if this sign is positive, so this becomes 3x minus 6x minus 3x. So overall, it becomes x square minus 3x plus 9, right? So now t dash 2x minus 3. So keep this thing equal to 0. So x is 3 by 2. So you have t 3 by 2, 3. Right? And you just put this value over here. So 3 by 2 square minus 3 into 3 by 2 plus 9. So 9 by 4 minus 9 by 2 plus 9 minus 9 by 4 plus 9 minus 9 plus 36 by 4 minus 27 by 4. Yes. Is it okay?
Plus
Yes,
37.
sir.
Plus
Sir,
27.
plus
Sir, plus
27.
Plus
27, sir.
27.
plus 27 by 4. Right. Is it fine now?
Yes, sir.
Yes. You with me? So you can check the points as well, but you'll come to know that your maximum value would be at 0.5 by 3, right? Which is 19, and your absolute minima will be at 4 minus 2, that is minus 12. Okay, so this is your absolute max and this is absolute min, right? Yes, got the idea?
Yes, sir.
Yes, sir.
Okay. So let's do few more questions. So this is question number 37. So we have f of xy is equal to 4x square, sorry, 4x minus x square cos y, right? And the plate we have given to be 1 to 3, x lying between and y lying between minus pi by 4 to pi by 4, right? So that's the idea. Again, let's draw it and see it how this can be formed. So in the last question, the line was x0, but here the line is x is equal to 1. And we have x is equal to 3, let's say here. And then we have pi, y is equal to pi by 4, and y is equal to minus pi by 4. So that is something over here and here, right? So let me mark these lines. So this is y pi by 4, y minus pi by 4, x is equal to 1, x is equal to 3, right? So this is the region where we want to get those limits. We want to we want to find out the absolute maxima minimum. So if you check those points, so this becomes minus pi by, sorry, this becomes 1 minus pi by 4, and this is 1 pi by 4. This is your 3 pi by 4, and this becomes 3 and minus pi by 4. Okay, yes, you with me?
Yes.
So
Yes.
let's first try the just try to find out the local maxima minima point. So you take the partial derivative fx. So this becomes your 4 minus 2x. Yeah, because your cos y is constant. In this case, your y is constant. Okay. So if you take fy to be 0, so that means you have 4x minus x square as it is, and you have minus sine y. Yeah, right? So now you keep those things is equal to 0. Okay. So 4 minus 2x into cos y 0 and 4x minus x square minus sine y is equal to 0. So now let me take this expression to the next page. Okay. So let me put it over here. I'll keep in mind that these are zeros. So either your 4 minus 2x is equal to 0 or your cos y is 0. So either your x is equal to 2 or your cos y is 0. So cos y 0 means what? Y is odd multiple of pi by 2. Is it right? Is it right? Are you with me this? Are you with me on this?
Yes, sir.
Yes. Fine. Fair enough.
Yes.
Okay. So let's now solve this equation as well. So this becomes either your x is 0 or your x is 4, right? And
Yes, sir.
your minus sine y is 0. That means or your y has to be n pi. That means multiple of pi. Fine.
Yes, sir.
True? True? See, but x is equal to 4, we cannot take that point. Why?
So because in the first equation it won't match.
No, this is not
Sir,
the
limit
reason.
is
Sir, it is
still
given in the question
It is given.
that
Yes.
Sir, we have to
We,
check on the
we have a
rectangular
very
plate.
smaller region. Yes, we have a very smaller region. This is the first reason to reject that point. Of course, you can put it over here. That will not match. That is another reason. But the very basic reason is we cannot include that point into our region because our region is much smaller than that. Okay. So 4 is lying outside our region. So we'll reject that point 4. Right? Fine. So now 2 is within the region. Okay.
Yes, sir.
2 is within the region and y is equal to n odd multiple of pi by 2 is again outside the region, right?
Yes,
Because
sir.
we are restricting ourselves from minus pi by 4 to pi by 4, so there will be no pi by 2, there will be no multiple of pi by 2 in our region, so we'll again reject that point. But yes, from here we can have a point that y is equal to 0, because if we choose n to be 0 as n your integer, so y can be 0, right? So if you take x to be 0, then you will not get any value of y, right? So basically you are left with what? You are only left with 2, 0. So from 2 you have this, you have 2, and this you have 0. So this will of course satisfy both the equation. You can check this. So if you put x is equal to 2 over here, this will become 0. And you put y is equal to 0 over here, this will become 0. So both equation will be simultaneously 0 if you choose the point 2, 0. Fair enough? Yes.
Yes, sir.
Okay. So 2, 0 is our critical point, right? See, if you take x to be 0, your x0 will satisfy this, but your y0 and x0 together will not satisfy this. Because if your x is 0, this will become 4, and your y is 0, this will be non-zero. So 4 cannot be equal to 0. So x0 and y0 cannot be an interior point. Okay? I mean the critical point. Right? You with me? Yes.
Yes, sir.
Yes, sir.
Okay. So this is only critical point, 2, 0 over here. So let's calculate the value at 2, 0. Our function. So you put 2 over here, this becomes what? 8 minus 4. And you put 0 over here, cos 0 will become what? 1. So your f20 is nothing but 4. Yes, right? So this is our 1 point. Okay, is it fine?
Yes, sir.
Yes, sir.
Tell me, is it okay?
Yes, sir.
Okay, so now let's start from the boundaries and then work on the boundaries as well. So if you put x is equal to, let's take the boundaries of x first. So first boundary is taking x to be equal to 3. Sorry, x to be equal to 1. So if your x is 1, so of course your f1y will become what? 4 minus 1, 3 times the cos y, so 3 cos y. Right? So now you pick f dash, so that is minus 3 sine y, and put it equal to 0. Right? So your y is 0, but your y can be actually n pi. So you have many values of y, that means minus 3 pi, minus 2 pi, minus pi, 0, pi, 2 pi, and so on, right? But the only eligible value is 0. Why? Because these all values are lying outside our region. Either they are right to the our region or they are left to our region. So they are not eligible candidates for us. Okay. So y has to be only 0. You calculate the value only at y0. So that is what? So if you pick that 0 over here, so that becomes 3. So that is one value. But since you are dealing with x is equal to 1 here, so this is the line, right, with which you are dealing. So these are two critical points. I mean, these are the two corner points which should be evaluated separately. So we'll get the values at 1 pi by 4 and 3 pi by 4. right? 1 pi by 4, sorry, 1 pi by 4 and 1 minus pi by 4 as well, because we are dealing with, sorry, this boundary x is equal to 1, right? I
Yes, sir.
marked the wrong one, not this one. We are dealing with this boundary. Okay. So
Yes, sir.
we'll calculate these 2 points separately. So 1 pi by 4 and 1 minus pi by 4. So let's say f of 1 pi by 4. So 4 minus 1 into cos pi by 4, that is 1 by root 2. So that is 3 by root 2. So if you rationalize it, it will becomes this. Similarly, you get the value minus pi by 4. You know that the cos of minus pi by 4 will also give you the same value, right? Because cos is an even function. So we'll again end up with the same value. So f of 1 pi by 4 will give you 3 root 2 by 2, and f1 minus pi by 4 will also give you the same value, right? So one boundary is done. Okay. Yes, you are with me.
Yes, sir.
Yes, sir.
Yes, sir.
Now take the next boundary, that is x is equal to 3. Okay. Again, so this becomes f3y. So 4 into 3 minus 3 square into what? Cos y. Yes. Is it okay?
Yes.
Right.
Yes,
So
sir.
this will again give you the same thing, 3 cos y. Right. Now f dash 3y, that means minus 3 sine y, you'll keep it to 0. So again y will be n pi, n belongs to the integer, but only y is equal to 0 will lie in, only y is equal to 0 lies in the given rectangle. Okay. So therefore points are, only point is 3 0, because x3 is already given and y0 we have computed, that's why. So now put that thing over here. So f30 will be, so you put those things over here. This is 3 times the cos 0, that means 3. So your f30 is nothing but 3. So since you are dealing with x is equal to 3, you're dealing with x is equal to 3, that means you have to calculate these 2 points separately. Okay. So these points are what? 3 pi by 4 and 3 minus pi by 4. So let's calculate it. So f of 3 pi by 4, this becomes, 3 is already there, you put pi by 4, just cos pi by 4. So again it will give you the same value, 3 root 2 by 2. And similarly, if you calculate 3 minus pi by 4, that is again 3 root 2 by 2, as we have calculated earlier, right? Now you are left with only two things. That's what? Y is equal to minus pi by 4 and y is equal to pi by 4. So let's start with y is equal to minus pi by 4. So this becomes x minus pi by 4, 4x minus x square into cos minus pi by 4. That minus will not make any impact. So 1 by root 2. So let's take f dash. This becomes 4 minus 2x by root 2, and we'll keep it to 0. So our x will become 2, right? Yes. You getting the stuff?
Yes, sir.
Okay. So now point is what? 2 minus pi by 4. So 2 minus pi by 4 is your point, and you just calculate the value on that point. So put it over here. So f of 2 minus pi by 4 will be, you put 2 and minus pi by 4. So we put 2 over here. 8 minus 4 into minus pi by 4 already we have, to get got that 1 by root 2. So that is 4 by root 2. Yes, fair enough.
Yes, sir.
Yes, sir.
You're getting that thing, okay?
Yes.
So that
Yes,
is
sir.
Yes, sir.
so that is 2 by, let's say 4 root 2 by 2. So that is 2 root 2. Yes, fine. So
Yes, sir.
similarly, now you get the point at, so 2 pi by 4 is there, right? You're done? Yes. But that corner points we have already evaluated. We don't need to evaluate again. Okay. So we have
Yes, sir.
started with y is equal to minus pi by 4. These corner points we have already evaluated. So we don't need to evaluate it again. Okay. So similarly, now you are left with the last boundary, that is y is equal to pi by 4. That makes your function to be f of x pi by 4. So you keep x same and put y to be pi by 4. So this is your 4x minus x square by root 2. Now again you calculate f dash. This becomes 4 minus 2x upon root 2. Keep it to 0. So this will give you x to be 2. So if your x is 2, so now you can calculate your y is pi by 4. So 2 pi by 4 is again your point, and f of 2 pi by 4. So you put 2 over here, 8 minus 4, 4 by root 2. So again 2 root 2, right? So now you have calculated all the values. Now you can tell about the maxima and minima by comparing these. Okay. Right? So you come to know that the absolute maxima is at 2, 0 with maximum value is 4, with maximum value to be 4. Yes, so that is something which we have got in the very first stage here, right? So that was our local maxima, which now has become the absolute maxima because it is giving us the value more than at any other point. And if you calculate the minima, that is already same. We have got over here, that is 3 root 2 by 2, right? So absolute minima is at 4 points: 3 minus pi by 4, 3 pi by 4, 1 minus pi by 4, and 1 pi by 4, with value to be 3 root 2 by 2. Yes. You got those things?
Yes, sir.